So today's tricky topic in 2 minutes is the connection between the changing kinetic energy of an object and the work that's done on it. So I want you to watch something here, okay? I'll demo for you. Yes, that was a pot moving across in front of me at basically constant speed, sliding across there. Now, the things to notice about that are, one is that I had to use a force to push it, right? And as I pushed it across there, it stayed at roughly constant speed. And what that means is that there was no change in kinetic energy of the object at all. Because kinetic energy has to do with 1/2 its mass times its velocity squared. Now that doesn't change. There's no change in the kinetic energy of that pot as it slid across the table. So if I was using a force, right, and obviously I did a force, I pushed with a force through a distance to make that happen, there had to be work being done, right? So if I used a force through a distance, I did work, okay? But there didn't seem to be any change in kinetic energy. So how does this work together? Because if we're learning that work in some sense is a change in kinetic energy, and I just did work but there was no change in kinetic energy, then there has to be something else going on here, right? So the idea is that if I push this across here, was there a force of friction? Well, certainly there was. And that force of friction was exactly opposite the force that I was using to push the pot across the table. Since that force is directly opposite the direction of the displacement of the object, that work that's done by friction in this case is actually negative. And amazingly enough, since it moved at constant speed, my force and the force of friction were equal. Should make sense to you at this point. And if those two forces are equal, but they're in opposite directions, one force produced positive work. In my case, that's me pushing it forward. And the friction produced negative work, which means that when you add the two together, the positive work done by my pushing and the negative work done by friction added up to 0 net work. So to finalize the story here then, yeah, the change in kinetic energy of the pot as it slid across the table was 0. And the way that makes sense is we understand that both kinds of work are going on here. Positive work that I do, negative work done by friction. If you add those two works together, it does add up to 0. And the net work, the resulting work that's done, is actually 0, just as it makes sense.